Do you see my presentation?
Yeah.
Okay, I hope I need from 15 to 20 minutes.
Okay, sounds good. Please, floor is yours. Go ahead.
Dear ladies and gentlemen, the following report is brought to your attention as structurally variable electric power system, PAPS, resistant to terrorist and military threats. Briefly, overview. For energy policy makers, designers, and system operators, the problem of protection of EPS is extremely important, which is solved by planning and investing in increasing the sustainability of the operation of and development of the power sector. The sustainable development of energy sector is ensured by organizational, technological, and technical solutions to the problem of stability, robustness, durability, and resilience of the EPS. The EPS as part of the energy sector and the system of organizational and technological management and response is on the path of sustainable development only in the conditions of untargeted actions on shock, threats, and critical loads. The causes.
Sergey, I'm sorry. Your slides are stuck, so it means could you please reload your presentation? We just see your first slide.
Sorry. Just a moment. Can you see?
Yeah, now we see.
Okay. Thank you. The causes of destruction and their consequences are the subject of many studies. We divide the causes of such destructions into purposeful, man-made, cybernetic, and physical, related to the human criminal activity, and non-purposeful of natural origin. Hurricanes, earthquakes, floods, as well as errors in the actions of personnel, so-called the human factor. For example, Russian missile strikes on the United Energy System of Ukraine lead to the loss of the integrity of the energy system, the formation of isolated subsystems with surpluses and deficits of electricity production and consumption. Operational balancing of the formed subsystems leads to a long-term blockout of the large number of consumers, which can have serious consequences for the population, especially in the cold period of the year. The largest number of publications is devoted to the problem of the protection of power system from non-purposeful destructions. Development strategies for minimizing the consequences of such destructions are implemented in the short term by improving the measurement system, and in the long term by planning the development of the system with a justified level of resistance to such threats. At the same time, the consequences of such threats are assessed by the economic losses caused to the electric power companies and electricity consumers. The problem of protection of power systems against purposeful destructions is less studied. Most of the publication is in the direction concern protection against cyber attacks, a much smaller part from terrorist attacks, and the smallest part from military actions. Research on the problem of the protection of the power system from terrorist attacks is limited to the impact of the individual subsystems and the modeling of such impact on the basis of the game theory and risk analysis. At the same time, short-term and long-term planning of the development of individual subsystems under the influence of terrorist attacks are carried out with the aim of minimizing losses to owners and consumers of electricity, and with the aim to maximizing the cost of terrorists to achieve their goals. Separate studies of the problem of the protection of the energy system from a large-scale military impact, similar to the one that the United Electricity System of Ukraine is currently experiencing, are not exhaustive. Such studies are carried out in particular by modeling the reaction of individual components of the power system to attacks and assessing the risk of the entire power system based on the components of an attack on components that interact with each other. The cumulative effect of direct and indirect damage of the overall functionality of the power system is taken into account also. From the review of publication follows that the problem of the development of energy systems in condition of large-scale terrorist and military threats requires further research. The purpose of study is to develop the concept of structurally variable EPS capable of providing stable supply of electricity to household business, housing, and communal services, transport, and agriculture of Ukraine in condition of terrorist and military threats. Sustainable development of regional EPSs, formulation of market management mechanism of regional EPS. The term structural variability is used in the sciences that study living nature and means the variety of changes of the structure or activity of a living organism that allows it to survive in the conditions of its existence. This term we use for the first time in studies the electric power systems. We will show how sustainable development of the energy sector in the face of terrorist and military threats can be ensured by supporting organizational, technological, and technical solutions to the problem of structural variable of the EPSs. Structural variable is the ability of the EPS to reproduce such a variety of subsystems and electrical connections between them, which enables the operator to control the structure of the EPS, and in this way ensure the stable operation of the electric power industry in conductions of purposeful destructive actions.
Sergey, I'm sorry for bothering you again, but we have some kind of issue with the slides. I see right now. What slides are you in right now?
Okay.
Oh. So just to mention, it's the last slide we saw was number 4. So now it's 8.
Number 4. Oh.
Okay, yeah, but just take this situation into account. Yeah, please go ahead.
Can you see my slide now?
Yep.
Okay. The slide number 8. Yes?
Yep, slide number 8.
Okay. The contrast of the problem of stability, resistance, robustness, and durability of the EPS, the solution of which ensures the stability of the development of the electric power industry in peaceful conditions, is shown here. Here is the additional problem of the structural variability of the EPS, the solution of which allows maintaining the sustainable development of the electric power industry in the different conditions of terrorist and military actions. The construction of a structurally variable EPS must begin at the regional level. Power generation, storage, distribution and supply of electricity in volumes sufficient for consumption by the households, housing and communal services, transport and agriculture of this region must be installed in each regional EPS. The definition of the boundaries of the EPS of the region is established according to the following 2 factors. In accordance with the requirements of safety and reliability of electricity supply, a greater degree of structural variability of the EPS and the greater stability of the functioning and development of the electric power industry is achieved in the case of dividing the national EPS into regional EPSs of the smallest possible size. At the same time, each regional EPS must be satisfied the demands for electricity of consumers who are able to reimburse the operational and capital costs of regional energy companies. Thus, the establishment of territorial dimensions of regional EPS is determined on a compromise of these 2 factors. The national slide number 10, yes?
Slide number 8. At least I see right now slide number 8.
Number 10, I would like to. And number 9 also losses.
I couldn't see right now. It's below. Just slide number 8.
Oh, sorry. Maybe in such manner.
Yeah, slide number 9. Slide number 9. Yeah, I see that now.
It's a previous. I already comment this slide, and the next slide is number 10, and I cannot. Okay. Yeah, you see number 10?
Yeah, you can see it.
Okay. The national EPS supports the regional EPS with agreed amounts of renewable and reserve capacities, and ensures the supply of electricity to enterprise of industrial constructions, transport, and other types of economic activity, which are of national importance and do not join the regional EPS. The analysis of locally graphs of electricity consumption volumes aimed at the livelihood of the region and economic activity in Ukraine shows their similar daily variability. Look here below, but noticeable difference in the dynamics of electricity consumption volumes aimed at the economic activity on working and weekend days. Number 11. There are also noticeable difference in the volume of electricity consumption aimed at the livelihood at the individual regions and accordingly and the economic activity. Therefore, the peculiarities of electricity consumption in the region must be taken into account when planning the development of regional EPS and their interaction within the national EPS. In the event of the destruction of the individual regional EPS, the national EPS, as well as the neighboring regional EPS, together provide the urgent needs of the affected regions in the amount of electricity sufficient to consumption by the household, housing, and communal services, transport, and agriculture. An example of the organization of cooperation in support of United Energy System of Ukraine and EPSS, regional EPSS, in conditions of targeted destructions of the EPSS, marked with the asterisk, is presented here. Coverage of electricity shortages in the destroyed regional EPSS is provided by national EPSS and neighboring surviving regional EPSS market with cycling within their territories. In the structurally changing EPSS of Ukraine, uniform rules of conduct for all energy companies as market participants interacting at the national and regional levels should apply. To organize such interaction, it is necessary to apply the mechanisms of decomposition wholesale electricity market. The diagram of the interaction of upper level and regional electricity markets in the condition of the decomposition of the wholesale electricity market is presented here. Decomposition of electricity market allows the introduction of market control mechanisms for the stability of the functioning and development of individual regional EPSS in order to maintain the necessary level of structural variability of the EPSS as a whole. And in conclusion, the proposed concept of the structurally variable EPSS is aimed at its modernization and ensuring sustainable functioning and development of the electric power industry. The concept defines ways to achieve the three goals: permanent supply of electricity to the households, housing and communal services, transport and agriculture in the region or in the regions of Ukraine, in conditions of terrorist and military threats, planning and development of regional EPS in particular generating capacities using renewable energy sources, formation of a distributed electricity market and market mechanisms of EPSS management capable of functioning in the special condition of terrorist and military attacks. Thank you for your attention.
Thank you, Sergey, for your presentation. Colleagues, do you have any question to Sergey? Okay, let me ask some simple question. Vyacheslav, please go ahead.
After you.
Vyacheslav, you raised your hand. You have.
Okay, after you, please.
Okay, I have some very simple question to Sergey. Sergey, slide number 8. Would you please go back to that? Slide number 8, if it's possible.
Yes.
Yeah, you mentioned some very interesting feature of the new system. Yeah, I'm talking about this one. Stability, resilience, durability, and robustness. My question is, it's a very difficult, and in my understanding, to make this system which completely meets all of the requirements like that. So it's in the same time being stabilized, resilient, and have some kind of robustness. My question is, is it possible to find the trade-off to balance this feature? If yes, how we can proceed with this balancing exercise? Because again, it's very.
What do you mean balances? What do you mean balances? Balance is about the stability, resilience, robustness, and durability.
Yeah. I'm trying. Yeah, balancing trade-off between these features which you mentioned. Because again, it's how much stability is enough, how much resilience is enough, how much robustness is enough. So how to balance your system to make sure it possess this feature in required definitely quantity. I would say this way.
Thank you for your questions. It's a very interesting question. These four factors, in contrast presented here, demonstrate the different requirements that power system must be satisfied in order to have sustainable development conditions for sustainable development. For example, if you talk about the stability, according to Ukrainian law, we determined static and dynamic requirements for these conditions. Static determined when the operations, current operations of the electricity system have ability to keep this regime or operation mode without looking at changing of the level of consumption, the volume of consumption of electricity in some range of changes, or similar changes. And dynamic conditions, dynamic stability, determine the possibility, the ability of electricity system to transit from current operation mode to another one in order to balance the generation and transmission and distribution of electricity to consumers, and to keep in such manner the stability, but in another regime, another point of electricity loads of the elements of the power system. This is stability. And the robustness is a more complicated process, mechanical and physical reactions on different situations with moving energy on the rotor of generation units, and the electricity, the electromagnetic processes in the generation units, and creating the specific regimes in power system that maybe lead to the destroy the integrity of the power system, and the special infrastructure elements of power system introduced in order to protect the stability, stable functionality of the power system. This is robustness. And the durability is a facility of the or properties or characteristics of the elements, of separate elements, and some subsystems of the electricity power systems that that guarantee that the electricity system continue functionality for a long time, and this permit to planning the regimes, to planning the investment process, to operate on the electricity markets in order to guarantee the supply of electricity and so on. And resilience is a specific demand to electricity that need the ability of electricity to protect the actions that lead to dangers of some elements or some subsystems, and not only protect but quickly restore functionality after before it's happened. This is resilience. But if we apply these four demands to the power system, to the current power system, it's not guarantee the sustainable development of the system. Why? Because when the causes of damage is not purposeful, aimless influences on this, on the EPS, on the left of this side, is systematic, is load variability, or episodic accident, disasters, nature, earthquakes, critical changes in the weather, and so on. And we cannot apply the method for stability, resilience, and robustness of this system. And reaction to the unexpected, maybe enough in case I'm less influence. But if the influence is purposeful, when the rocket attacks have specific purpose to destroy integrity of electricity system. And in this case, it is necessary to change this, the power system itself, sorry. And in such manner, for new system, we can apply the demand of stability, resilience, and robustness, and develop to solve this problem according to the new system. And this approach presented here in this report, in this investigation, how to do this.
Okay, Sergey, thanks for your response. Dmitry, your question?
Yes, thank you. I have a question too. My question is about slide number 4. Do you think errors in software?
Wait a moment.
Yes.
I show this slide. Number 4, yes?
Number 4.
Okay.
Do you think software defects can be classified as destructive factors?
Repeat your question, please. I'm sorry.
Do you think software defects can be classified as destruction factors?
Software defects?
Software defects, yes. Errors in software.
Errors in software?
Many devices in power systems has software and
Oh, yeah, I see. Yes, this also purposeful man-made, for example, cyber attacks,
yes,
may
for
be
example,
destroyed. And this is also the critical problem. And I don't include in my attention this problem, and this problem must consider separately. And of course, the software, the distributed software, must be protected to destroy it. And it's a problem. It's a separate problem. But this problem must be solved according to the to those power systems that now exist and planning to the future development.
Sorry, why do you think that software defects is separately problem, but the results of its influence the same as you told in your report?
No. The result, yes, I agree, but I don't agree with the same, because I'm talking about the new structure of the electricity power system, new structure. And this new structure demands new software distributed on this structure.
Yes, of course. Yes.
It's reasonable. And a new structure demand the decision of protection of the and decision the problem of cyber attacks. I mean this one, and in this one, in this in this case, I think this problem must be solved in other manner that when we try to develop the software protection cyber system applied now for the power system, for United Power System of Ukraine. It's with the development of electric power system must be development of the cyber system protection. It's closely linked processes.
Thank you, Sergey Ivanovich.
Okay, any other question, colleagues?
Maybe.
Yes, I would like to.
Vyacheslav, you first one? Yes. Okay, please.
Maybe not question, just comments, because a question of Professor Majewski was in the same direction. I would like ask about cybersecurity issue in context of 4 factors, 4 attributes which Sergey represented. Because if you talk about resilience, part of resilience is related to cybersecurity. Yes, and if you talk about stability, cybersecurity can be reason of changing of stability and so on. Hence, I think it's very complex task to present all factors, because hence I think a model which we discussed is a high-level model. It's a start point to top-down go ahead. Yes. Really, software reliability is a part of any digital structure. Hence, we need understand how we can take into account. But it is not high level. It's maybe second or third one. It's very important issues. But we need to go ahead step by step, top down. And so I think this model can be efficient because it is a start point for analysis of such problems.
Yes, I agree. Thank you very much for your comment.
Yeah, thanks, Sergey. Thanks, Vyacheslav, for your question and your presentation. If we don't have any other question, I invite